Hi, welcome everybody. I'm Giulio Sandrini. I'll be your host for this 30 minutes or so. And I'm going to present the kind of sneak peek at the development of our new unified fitting and modeling framework in the Wolfram language. I'm the manager of machine learning, and we are kind of like incubating this framework for a bit in the team, and I think now it's time to show it to the world. So, like, keep in mind everything I'm going to show is highly experimental. We are going to have a 0.1 release, or like 1.0 release for 15, but this is under active development, and we're also happy to take suggestions if you have. Okay, so let's start with what we currently have in the Wolfram language. The landscape is quite fragmented. We have a bunch of statistical model fitting functions, like linear model, generalized linear model, nonlinear model, plus some specialized version of generalized linear model like logit and probit. We have local model fitting introduced last version to be able to handle non-parametric regression. We have machine learning functions like classify and predict that are very powerful, but somewhat opaque compared to standard statistical inference. And then we have a couple of like workhorses, like fit and find fit, that are like basically, like nice interfaces over the base optimizers. So for like linear and nonlinear fitting specifically, but they don't deal with data per se. They are just like simple interfaces. Plus, we do have specialized functions that are, like similar in name and spirit, but they cover different domains. So we are not gonna touch that today. Like time series model fit, estimated distribution, estimated process, region fit. I mean, all of these are like very specialized and kind of like a bit beyond like standard statistical modeling. Okay, like what are the pain points of this framework? I mean, the situation right now. Like you have different interfaces and they give different outputs and they cannot often be compared. For example, like linear model fit and classify, not obvious. There is no unified way to select then the models across different paradigms, because like you need to kind of write them differently, train them differently, and it's also cumbersome to extend, because adding new model types, as we discovered when we tried to when we took over basically the statistics and try to add local regression, you need to add a new called fitting function for each model family, basically. Okay, so what's our proposed solution here? Unified framework. So one interface, any model, and an extensible architecture. So the idea is that you have like a centralized function to perform the fits. And then you have model families and data that are both ingested, and this function will know about different model types and different data types, like quantities or units, date times, categorical object that have been presented like during this WC. And at the end, you have different paths like standard, evaluation, like numerical evaluation or symbolic evaluation, or like report if you're interested in that. So it's basically a single entry point for the framework. Let's see, what are the three components here. We have like model objects. And these are, composable, extensible, if they can, like fully symbolic. So you can use polynomial model, decision tree model, power model, single trainer, and smart reports like classic, ANOVA, parameter inference, residuals, or for ML models, you could have like stuff like feature importance, cross-validation metrics, specific model properties like tree depth and things like that. So basically, this is kind of the concept of this. So let's start with the model object. How do we write it? Ideally, you have a model head. each model will have its own documentation page where we can actually have finally some space to, like not talk about like on result properties or fittings or stuff, but we can talk about the model per se. Why would you want to use it? What the different model parameters mean. And like when you're doing selection on hyperparameters, like, how does a decision tree work? You can have like a lot of examples like that. And so the structure is like you start with the model head. If you don't have any hyperparameters, like you're fitting a simple exponential, you're good to go. Yeah, like you just plug it in model fit and you do inference for you. You can plug in hyperparameters. You can specify variables if you want, and still a bit undecided if you want to put here or here, like to preserve legacy argument structure. But you can manually specify parameters if you want. Let's see a bit how this might work in practice. Yeah, like for example, here you have a polynomial model of degree 2. And I'm manually putting in parameters, and I'm putting a variable x. Yeah, so like this is a complete expression. You could do other things here, for example, like not putting parameter explicitly, but you just put automatic, and that means that this is not a complete model. It's just ready to be fit by the framework. And here I'm also adding another sneak modification, like I'm not saying x, I'm saying 3. So this is just a quick way to give the input size and to generate like a long polynomial of degree 2 in 3 variables. You can customize the variable names, of course, if you want. And this works for linear and nonlinear model. There's a similar idea for decision tree models. In this case, I'm using kind of a short syntax here, like a bit longer than this, because I have more than one hyperparameter. So I just qualify one max depth. I'm not gonna specify custom parameters here, so because like this is technically a non-parametric model, so it doesn't really. I could pass like a build tree already at the beginning, but it typically doesn't make much sense because that means you already have it. And again, we are trying to use this as an entry point to different areas of the language. So you can, for example, have like parameterized neural models that will train neural networks using the same framework, same data, easy to compare. So that's basically the idea. Now, once you have defined one of these, you can just evaluate it. Like if a model is fully qualified, you can evaluate it on a point, and you get a result, or you have like fast vectorized evaluation. And same thing if you have multivariate models here. I'm not putting parameters, so it's symbolic, and you see that I have like right now I'm using this C thing. Let's see if this survives design. But this is a constant, integration constant symbol that is used in like integrate and desolve. So like, why not? We already have a symbol for that. So this is like degree 2 variables. I'm just passing 2 points here, and you see this is like fully evaluated. Now I'm playing here with like these models, like I'm putting values here and not putting values here. Like there's, this thing here is a like fully trained model. There's no, like we haven't even showed the fit function yet, but there's no substantial difference between an like a initial model with no parameters and a fit model beside the parameter values being actually there. So like this is something that I'm trying to enforce, at least for the simple algebraic models. So there's no particular distinction between those. Now, what's the model hierarchy? I mean, right now we're trying to put together this as a family, where it's going to be easy then to kind of extend it that way. So like for linear model, we have like simple polynomials, Fourier models that I'm actively working on right now, and probably version 2 generalized additive models. Non-linear model, of course, you can use linear and non-linear alone, but you have like nice shortcuts, like power model, exponential, log, that can be used like to keep track of different model types. And then you're going to have like models like trees. In the future, I want to add ensemble models to this framework as well, and like specialized models like neural networks or k-nearest neighbors for classification and regression. Other things that I forgot to put here for the future could be support vector machines, for example, or Gaussian processes. Like things like that are more easy to add to the framework. Now, let's look at this in practice. So this is kind of a core of the functionality. This already works now. Is still under like very active development, so like it's gonna move fast. But the core functionality is all in. So what's the challenge for today? Like a pretty simple problem: 200 observation, noisy, 2 input variables. We don't know the functional form here. We try to find best model. Here I'm also using the plot fit functionality, which is quite neat for these demos. Now let's pull up candidates. So here I'm just writing models in the like fastest form I can, and I'm leaking through some like extra goodies. For example, here I'm using symbolic polynomial model families with an up to syntax. So try like 0 to 5. Power exponential log model, like 3 type of nonlinear model, a custom linear model where I can manually select interaction terms. And then I'm trying to non-parametric model like decision tree and with 5 neighbors, and decision tree and nearest neighbor with 5 neighbors. Okay, so we define it, and then we simply run model fit. So here for this, I wanna compare them, but if you don't care, you can just directly get the best model out. Yeah, so like this is ready. This is the parameter filled in, and you can use it. But and if you're using this as an optimizer, that's perfectly fine. But the interesting bit is to get the report out. So right now I'm packaging this in something called model fit report, which has beside properties has also some visualization built in, so you can have a look. Oh, this is very small in the. You can see it in the presentation mode. This standard residual quantile plot of residual, so you can use to check quickly what your best model is doing. And most of all, you can compare if you have more than one to get this bit. I'm using a development build, but you can compare like how different models that were trained are faring in terms of performance and overall loss, like cross validation loss. So what happened here, like under the hood, we trained like all 11 models. We trained them using the default validation set, which is k-fold cross validation with 5 folds, but you can override it, of course. Computer performance metrics, like they're all like stored under the hood. We've selected the best model and retrained that on the full data set. Like I mean, we don't reuse the cross validation models for this. Statistically, it's better. And then at the end, everything is packaged in a report object. Okay, so what can you use this fit report for? Okay, this goes a bit beyond. There it is. You can extract properties, of course. So let's have a look at why we picked the polynomial 3 model. Well, here you see the cross-validation losses. The nice thing about this is that you have a nice spread, and you can. It's not just a one-off like AIC criterion when you train a single model. You get immediate out of distribution performance estimate, and you see, for example, here that clearly power exponential were wrong functional forms were very bad. All the polynomials are pretty consistent here, except degree 1, like the and like polynomial 3 is winning by little margin compared to polynomial 4. 5 is going up. That means this is something that is difficult to do if you don't have cross validation. 5 is going to be better than 4 and 3. But here we see that using cross validation, we are measuring not just the underfitting but also the overfitting. And the other models like around here, they're not particularly good. The nearest model is decent, but it doesn't capture enough to work on the out of distribution example. And you can use a report to build your own thing. For example, here I'm creating like a tabular with not model short name, validation, and training loss. So it's essential to have validation loss because, for example, nearest model we have 0 loss on training by construction. So yeah, you really want to be able to look at these kind of things. Okay, beyond this, we do give you access to all the properties that you know and love from a linear, nonlinear model fit. Like let's look at the BAC, ACR squared of the best model, for example, or here, or parameter estimates with their own t-statistics and their p-value, like an ANOVA table for all the terms. So you can already abstract these things, but we added these to this new framework as well. And let's see, like you can extract under the hood cross-validation properties. Like here, for example, we can see the performance across each fold for all model types. So you see like polynomial are pretty consistent, while there's high variance for like other types. Like the decision tree is moving a lot. Also the individual linear model it's being thrown here and there because they don't have enough term. We can compare like inner model statistics like loss against training time or things like that. And I'm trying to basically store as much as I can in an efficient way so it can be recovered. Well, once you have fitted the model, what can you do with it? Let's assign the best model to a variable, and need to work a bit on like shallow is not a great way to show formulas here. You can use this model as a function. So this takes 2 inputs. So I'm just running this on the list, and of course you can plot it. We've been working a lot with tabular data. So if the input of model fit is tabular, you can directly fit tabular columns, and you can use the model inside the transform columns or construct columns to the idea here is that if your model is a matrix, fine, we just use data. If your model is like richly annotated, we take that into consideration. The nice thing about this type of model here, like given that it's a linear, you don't need to extract formulas or anything. You can use this symbolically. Take derivatives, integrals, and things like that. This is like all very easy to do directly. Then we have some advanced features. Some of them are already in, like instead of messing up with options, we are probing the avenue of using meta models to do several things. Like in this case, I'm using it to add regularization. So I'm training this polynomial model with degree 2. Actually, degree 2 is boring. Let's train it degree 10. And where you can see that most coefficients are 0. And we can actually evaluate this on something like x1, x2 to see exactly what stays there. And the nice thing is that here I'm putting L1 goes to 1, but I can just not put it and let it do cross validation on the like this. There's a lot of order. No, I know why. Like fit is not particularly happy. There's a little hiccups here and there. This is trying too many cross validations. So let's try just 2 of them, for example, to show that. So for example, 0.1, 1, and 10. There. So this is you can we are filling in right now automatic values if you don't specify parameters. So like reasonable guesses. But you can the core principle here is reasonable guesses, well documented when we can. Always give the ability to fix all like values yourself. Yeah. So this is like meant to be like a full control framework. Then another thing here, for example, data types. here I'm mapping a decision tree. Like this is regularized by default, so you get you get particularly short formula, like very many people, especially if you're male, you die, which is like not overly wrong in the Titanic dataset. But here you can see like some like we are borrowing from like classify and plot. So you can, for example, do survived here, and we just feed survive. And maybe you don't know these datasets. So this dataset is class, age, sex, and survived, true, false. So here we are predicting automatically a Boolean variable, and we are taking care of this categorical variable and this string variable. Yeah, like this is another thing I have as a goal for the framework. Like whenever we can like cast thing to categorical inside or numerical and deal with it, we do it automatically. Again, if you don't want this, you can just give your own pre-processed dataset, and at that point you're just gonna honor that. The idea here is, for example, let's say that we want only fit like class and an age. So we do something like class, age, survived, and we close it. So yeah, I mean, without sex to split on, there's more. And the full syntax of this is like kind of looking at the future, you can do something like this. So right now we only support this, but among the extension, we could have something like this. Yeah, like we are ready to go here. Another thing that I quickly shown, I want to kind of spend like 10 more seconds on that, is like a quick, compact way to specify model families. Like all hyperparameters are hooked up to the cross-validation. So here I'm trying, a neighborhood of different sizes for the nearest model, or up to 10 degree for the polynomial model, and these are all cross-validated together. So yeah, this is like something that I think it's really convenient. Okay, so let's have a final look, and then I'll take questions at what's the current status and the roadmap for this. So what you get right now, I mean, like in the build I'm using now, which is what will be, like the minimum of what will be in 15, so the upcoming version. You get the core framework, model fit, the model objects, and the fit report. You get like basic statistical models like linear, polynomial, also nonlinear, and the friends, like power exponential log. You get the first batch of ML models, like decision tree and nearest. You get a few specialized models like Fourier that I'm really working on right now, so it's not really optimized, and neural, which is actually working, but yeah, still need to tweak it a bit. You need automatic cross-validation and model selection. And by the way, if you're curious about that, I feel like why not also having cross-validation for single models? So you can, if you specify validation set, which can also be external, you can measure performance for a single model out of distribution quite easily. I mean, the idea is that you can use this for basically not maybe all your needs, but very many. And you get model families. Coming soon, stuff that we have like just sketched, but I'm probably not going to make it for 15, so they're going to be 15.1. Generalized linear model and additive models as well. Oh yeah, I put it here. So generalized linear model, feature parity with the linear model fit. So we are almost there, but not totally there. Like I don't know if I'm going to be able to add categorical variable support for the linear models in this version already. I'm really trying to. But there's also weighted data that I'm quite sure won't come up in version 1 of this. But the idea is basically that if not in the next version, in the version after that, we can completely supersede linear model fit, non-linear model fit. Yeah, I mean, basically, so we give all the same features plus more. Additional ML models like random forest, SVN, Gaussian process, all these. I mean, we have code for, but not gonna make it for version 1. Additive models, like generalized additive models, maybe some mixed effects models. Advanced categorical handling, yeah, I already mentioned that, like is not really in version 1 by default. And I think there's people pushing me for more advanced parameter, like hyperparameter selection, using sampler functions and things like that. But yeah, I mean, we don't really have time to put it in version 1. And I think this is already, I mean, I'm not the best person to judge maybe, but I'm enjoying using the framework. So I think it's already at a good step. Like future exploration that we are thinking about, peak fitting, differential equation models, hierarchical mixed effects models, like all these we have looked at, but we haven't a clear idea about how to put them in already. Okay, so key takeaways from today's talk. What you get: one interface that works with statistical, ML, specialized models, automatic cross-validation and model selection, and rich diagnostics. For developers, like the architecture is very extensible. Like it's easy to add specialized models. There's a nice inheritance system. So if you add, something which is based on a linear model, you can just paste on linear and don't copy most of the code. If you want to add something on top of the tree model, you just do that. Reporting is also easy. Like each model declare their own report properties, so the fit report can just like grab them. So yeah, and the idea is that we make the marginal cost of adding a new model very, very low, without the need to every time modify the core framework. And what the whole ecosystem gets as a whole, well, just one stop will make hopefully better science. We do fair comparison across different paradigms. We have a consistent interface, like you don't have to relearn this multiple times. And as much as we can, we leverage Wolfram Language symbolic power. Okay, so this is it. Thank you. I have a couple of minutes. So sorry, I rushed this a bit. I realize now, but let me look at the questions. Okay, first question. No, yeah, this not will be 15.1. That maybe I said that incorrectly. This is for 15. So this is really up and coming. And now person is asking me, can this general framework handle implicit models that are based on ODEs? Not yet, but I'm looking into that. This is in one of the future directions. We want to extend this. So no right now, but we are very interested in that. Now, let's go down. Will local LOES be supported? Well, yeah, we do support LOES in local model fits, and we plan to, as a plan to kind of merge all these high-level features in this. We're gonna put it in, just be called local model, for example. Now, media mix modeling. I'm not super familiar with this, Michael. If it's mid-mix effect modeling, we're talking about something else, but reach out to me and we can definitely discuss that. Now, support for multiple response variables. Yeah, touch that. So very, very close future addition to the framework. Like this is gonna be in version 2, most likely. I mean, the one issue with that is that some models can handle that directly, like the neural models. There's no reason not to, and the framework as a whole is ready for it. So yeah, I mean, I don't see many difficulties. Now, a couple of people are asking about random Monte Carlo causal models. Well, causal modeling we don't have in the language. This is like another completely different avenue we want to explore. But I honestly don't know enough of like Monte Carlo models to comment on how easy it would be to add them. That's something we can discuss. I see that both Robert and Michael are interested. Now, a person is asking, I'm not statistically fluent. Is there some place I can find definitions of my statistical properties? Well, yeah, one thing that will go with this definitely is documentation improvement. So, yeah, I mean, each one of those have like each one of these has like an reason why you might want to look at it, and different per dictionary in different fields are like they care more about one or the other. So we definitely need to do a better job at explaining them and why they're useful. I mean, many of them are already computable, but it's true that we don't have great documentation. When fitting, is there a nice hyperparameter search option and monitorable? Well, right now, monitoring we haven't added yet because this is typically very fast. Like even with a lot of, I mean, unless you do extensive grid search. But yeah, in that case, we might think of adding it. Everything like goes like what I did today goes like in milliseconds, and even if you have a very large data sets, it goes in milliseconds. The main issue is probably when you have like an extremely large number of columns and you want to try very many configurations. So if you I haven't basically paid much love to the monitoring for those extended use cases. I tried those to make sure that everything works fine. But yeah, I mean, there's nothing wrong in adding nice reporting, honestly. I think that's a great suggestion, Michael. And maybe I think I didn't put in here in the future actions, but yeah, more advanced hyperparameter sampling options is something we want to add for version 2. Let's see if I have answer everything. Yeah, I can make the notebook available. I'm not really sure on which version. I mean, it's more for your per-use than actually like just as a reading artifact than actually coding thing. Because yeah, I mean, right now this is all in development branches. But yeah, sure, I can add this notebook to the presentation, to the talk page. Let's see, any more question? Okay, so Gareth is asking, how about taking a model specification and using it for, say, all subset models to produce a table for AAC ranking? So I'm not super sure about what you mean here. I mean, you can get one thing that I didn't show is here, for example, in the report, you can get AAIC for all the models. Some of them don't have it, you know, the one that are not based on a formula. But for example, one thing you can do is to do, for example, loss. Oops. Versus AIC, and I don't know. I mean, one thing I'm doing a lot is like building these custom plots and tables. And this is one of the reasons I really started working a lot on this report object. And you do something like also, I don't know, short name, and probably something like call out of 1 and 2, and you want to do call outs on 3 there. So yeah, like this, for example, let's see how AIC compares to cross-validation loss, and you see there's a pretty decent correlation. So AIC, even if AIC doesn't see anything outside the training set, is not making a bad job, and you can and you can still it's a decent thing to use here. So yeah, and lookup is this. I mean, of course, you can then sort by this. Like once this is here, you can use this for sorting and whatnot. Okay. Anything else? Let's see. I don't remember if I answered the ODE. The ODE-based models, but this is something I'm discussing actively with the team. Is like differential equation and different equations as model is a direction we are really curious about. Okay, well, we are like way beyond talk time, so thanks for staying with me till the end, and I'll see you around if you have like extra questions or you want to get in touch, like some personal recommendation. Again, this is a moving framework, is under development, so I'm super happy to take suggestions.